Good evening. We will now see one of the MiniTube applications, and especially applications to yeast nutrients. We will see a number of features of yeast nutrients, especially nitrogen nutrients. Very briefly, you have here a summary of what you will be offered. The nutrition of yeast and nitrogen nutrition will be addressed. We will see the differences in inorganic and organic nitrogen. We will focus on amino acids, and we will see which ones are present in the nutrients and what functions they perform for the metabolism of yeasts. We will then see how that relates to one specific product as an application which can maximize the aromatic properties of yeasts, and it is WinTube fructale. You understand from the name itself that you have tube and fructale, and WinTube is the name of this range of products that was obtained thanks to the MiniTubes technology. And then we will also see the components of the WinTube range. Let's now talk about nutrition of yeast. We all know that yeasts need a number of nutrients for the purpose of alcoholic fermentation. First of all, nitrogen, which is ammoniac salts, inorganic, and more recently it is organic nitrogen, which means yeast derivatives which provide small peptides, proteins, or free amino acids that contribute to the nutrition of the yeast. The yeast also needs fatty acids and sterols, which are survival factors, and again, yeast derivatives, because they make out the cell membrane as well. And then we also need mineral salts such as magnesium, and which is used in beer in order to favor resistance to alcohol of yeast itself. Well, then of course we have vitamins which act as catalysts for the various biochemical reactions, and they need to be suitable. And then we can also have components which come from the yeast itself or which are exogenous, such as cellulose, which can provide that support function. And I just listed all these things to tell you that the substances that are used to support and nourish the yeast either come from the yeast itself or are ammoniac salts and exogenous supports, including cellulose. This is of interest when it comes to the practical applications of MiniTubes. Now, nitrogen nutrition. We have several works in literature we can refer to. You have here a table which acts as a sort of scheme and summary, which simply tells that you can obtain different results from the administration of organic or inorganic nitrogen to yeast. So the former, the organic, is a derivative of the yeast, and the inorganic is a salt. There is some debate about this, but I can tell you that generally if you use inorganic nitrogen, you have more biomass, and also fermentative kinetics is higher. And then with higher doses of salt, you might have problems, because if you have a high biomass, you need more nutrients, and this could stop fermentation. On the other hand, if you have fermentative kinetics which is too high, in case of lack of control of temperature, well, there you might have, again, problems. And I would like to underline what was a more, or what is a more organoleptic type of perspective, which is the following. If you use ammoniac salts in general, you have a sort of dry hint. And on the other hand, if you use organic nitrogen, you have more spidity, which comes from the amino acids themselves too, and you have more roundness, which is more related to manoproteins, say, that are present in the yeast derivatives themselves. Let's see now what happens when we have nitrogenous nutrition and aromas. In general, when using both organic and inorganic nitrogen, you have an increase in total aromas. That is world known. Then you can consider the production of acetates and esters and so on and so forth. And it seems that we have a higher production of ethylic esters and acetates with the inorganic nitrogen, while MCFA esters are more linked to organic nitrogen. In addition to that, we might have an effect on the varietal expression of the grape, which is the release of terpenes and thiols. Inorganic nitrogen seems to have a negative effect in this respect, especially at high doses. It inhibits not only the synthesis of the precursor carrier, but it also competes with precursors for entry into the cell of yeast, where you have the elements that could release it. So in those cases, it would be better to use organic nitrogen. And yet, this raised a question that we sought to find an answer to, also by means of practical experiments. And the question is organic nitrogen, which can come from 20 different molecules, differs, and it differs depending on the molecule, because amino acids can be absorbed at different times, and they can favor or be detrimental for the development of certain compounds. And so we wanted to investigate that aspect. Let's see how the yeast metabolizes these amino acids. What you see there is the formula that makes it possible to assess YAN, which is a parameter which is used extensively to predict whether you will have problems or not. And you have NH3 and FAN, and it is not all the nitrogen which is present in the fermentation pool that is involved in this phenomenon. I will now offer you this table where you have a summary of all amino acids that you can have in must. Specifically, in the fifth column, you see the percentage of nitrogen, and you indeed see that depending on the type of amino acids you have, for instance, arginine, 4 atoms of nitrogen in the molecule, and the percentage of nitrogen is higher, therefore, because it is as much as 32%. And the reference is the ammonium salts, which give 20%, for instance, at a dose of 10 milligrams per hectoliter. So this leads to tyrosine, which has the lowest percentage. This does not immediately translate into YAN, because we said that YAN is linked to FAN, and you see that there is less than expected in arginine. It is also true, though, that yeast manages to degrade arginine as a molecule entirely, and so it will be able, during fermentation, to assimilate in a number of cases fully. And this is positive, so that the nutritional value of this amino acid is rather high, and you can also have fermentation byproducts which can have negative nuances, both in organoleptic terms and also in terms of your health, because urea can be formed and cancerous substances and amines too. Then we have amino acids such as histidine and others that are precursors of substances which are not desirable. If you have indigenous yeast, you can have biogenic amines as a consequence.
Proline and methionine are two specific amino acids. Proline is generally not assimilated by yeast in anaerobiotic conditions, and so it has a very low nutritional power, close to zero. Methionine is a precursor of some off flavors like methanol, and it can also cause other types of problems, as we heard yesterday about livestock taste. And so actually the fact that there's not much of it can be regarded as a positive. Also, an excessive increase in proline and methionine and an excessive presence of both correlates statistically with an increase in acetic acid and methanol. You have other amino acids such as glutamic acid and glutamine, which are particularly important in biosynthesis, and obviously they should not be missing from the amino acid pool. There's another category of amino acids that seem to have a very positive effect onto the aromatic expression of yeast, either because they are direct precursors of some aromas, such as phenylalanine is a precursor of beta-phenyl ethanol, which is a floral aroma, or leucine, which is a precursor of isoamyl acetate, which is also positive, and others such as threonine and lysine, which seem to correlate positively with the increase in fermentation aromas. Another interesting finding came from a study carried out by the University of Zaragoza in 2002. The researchers had analyzed the amino acid composition of certain musts and had correlated the presence of various amino acids with the final result in terms of the aromas produced by the yeasts. In particular, they had run tests adding individual amino acids, and there had been an interesting effect which was found to be statistically significant, particularly with the combinated addition of THR and lysine, which was increasing ethanoic acid, ethyl butyrate, isoamyl alcohol, hexanoic acid, and so forth. Also, increasing phenylalanine, beta-phenyl ethanol also increased, increasing proline plus methionine. It had an increase in methanol and acetic acid. By the way, proline is one of the prevalent amino acids in must, and is one of those that are less often metabolized. We also ran fermentation tests in the lab using as our substrate a standard amino acid complex, trying to increase the levels of the individual amino acids. We increased in particular to increase the level of glutamic acid and glutamine, leucine, lysine, phenylalanine, and threonine, keeping the overall APA increase, which was given was resulting from non-organic and organic nitrogen around 80 milligrams per liter. These are the results on the fermentation test of a Pinot Noir must vinified to make a white wine. In terms of fermentation kinetics, the best performance came from the sample where the glutamate plus glutamic acid had been added. But what we found particularly interesting was the sensory outcome. Now, compared to a standard amino acid mix, the glutamate plus glutamine sample was not so appreciated because of its aromas, but wherever the other amino acids had been increased, the panelists seemed to prefer the aroma, that considering the total aromatic intensity equal among all samples. There had been particular increase in fruit notes. In terms of flavors, the tendency had been more or less the same, but it was less significant. All these assumptions and tests provided a basis for developing a specific nutrient for yeasts in order to maximize the aromatic expression of the yeasts themselves. WinTube fructol. This nutrient contains exclusively organic nitrogen, and the most important thing is that it contains a well-balanced amino acid pool or mix where we tried to maximize the presence of amino acids that play a positive role, trying to keep the amino acids that might have created off odors or flavors during fermentation at their minimum, or also trying to minimize components such as riboflavin, which is certainly an important vitamin, but when present in high doses can cause problems, particularly when the wine is bottled in light-colored glass. Let's look at some tests that we ran with this product. We saw that, for instance, with a Trebbiano, the volatile acidity and ethyl acetate prevalence was less than compared to other organic nutrients that probably were not so well balanced as to the amino acid mix. But also WinTube fructol decreased the presence of superior alcohols in total, and it increased the synthesis of beta-phenylethanol, which has a scent of rose and violet. This nutrient showed an increase compared to the other organic nutrient with medium chain fatty acids and acetates, with an overall note that plays up the fruit and floral notes on the whole. Now, let's address the meaning of WinTube. WinTube is an acronym that stands for Wine Yeast Nutrient in Mini Tubes, using the Mini Tubes technology. As we saw in the video, and as Mr. Granata discussed, this technology was developed in order to solve some practical problems that people saw in the wineries when using certain adjuvants. Since organic nutrients that release organic nitrogen come from yeast byproducts, one of the most problematic compounds to use in the winery was precisely that byproduct. Now, thanks to the WinTube technology, it's now available in a form that is easy to dissolve and use to obtain also many other advantages that I will clarify in the slides that follow. This is the slide I had shown to you at the beginning, because it summarizes all the things that yeasts need to carry out alcoholic fermentation correctly. The interesting thing is that all the raw materials that are needed by the yeast to produce nutrients for the yeast, well, actually we managed to combine them with the Mini Tubes technology. Now we have a complete range of products called Mini Tubes to feed yeast, meeting all its needs. Let's see what the WinTube can do compared to the traditional nutrients and what's lacking in it. Now, we don't have so many lumps to begin with, so it's a lot easier to prepare it. Also, the nutrients are more available because of the ease of preparation, but also because these nutrients are more available to be directly integrated during a yeast rehydration. WinTube also increased the absorption power, the support, and also the presence of oligoelements and vitamins that we took particular care in improving, particularly when with reference to magnesium and some vitamins that needed to be maximized because they can provide a positive effect and minimize, on the contrary, the content in terms of riboflavin. And the benefit that everybody can see is the ease of mixing of these nutrients. WinTube is now a range. We managed to prepare a product for every individual need. So first of all, we have WinTube Prepara. I'll just illustrate how they're used and what they're for. This is the specific product for when rehydrating yeast. The WinTube Full is our most complex and comprehensive set of nutrients, including all the different nutrients, nutritious elements that yeasts may need. It's the very comprehensive, and it can be used at the beginning of fermentation or at almost close to the end, 1/3 from the end. And it's also good for aromatic expression. Then WinTube Pro Life, which has a high content of yeast cell walls, and it's used to supplement and detoxify, and it can be used at the beginning of fermentation, 1/3 of the fermentation, and then during the lag phase, particularly if the fermentation gets stuck. Last slide. This is ProLife's performance. It's studies that have been made on endogenous toxins. It has an ability to absorb fatty acids during fermentation, although we've ascertained that actually the absorption is also exerted onto exogenous toxins such as residues of pesticides, but this will be dealt with by the next speaker. So I'd like to close my presentation and leave the microphone to Giorgio Nicolini, who will discuss the rest of the overall subject.